Greetings viewers, this video will go through Cambridge A-Level Further Mathematics, Syllabus Code 9231, and for the further Pure 2 paper. This is variant 4 from the May-June 2025 series. We'll go for question 2 now. The previous question I've uploaded into the playlist already. They want us to find the exact value of this definite integral given limits from 1 to 2.5 of 1 over square root of this quadratic expression. First, if you recognize this type of integral, usually what we straight away do is just complete the square, because there's a lot of different available type of integration where there is this situation 1 plus x, or x squared minus a, right? So we want to get it into this form. So we'll just go and complete the square and in the square root. So I'll just rewrite the integral. But this quadratic expression, let's complete the square here. So it's x minus 1 squared, and we'll have a minus 1 squared, right? So plus 5. So remember to write the dx with respect to x. So this reduces to x minus 1 squared, and this 5 minus 1 is 4, which I'll write as 2 plus 2 squared. Then what we're going to continue to do is I will take the 2 outside of the square root, and therefore, I mean the 2 squared out of the square root. So it's a constant, so we can take it out of the integral as well. So what happens is that this the divided by 2 squared, I can just bring it inside together, so the whole thing can be squared plus 1. And this will be dx, and don't forget the limits. Okay, now from here we can use a substitution. So maybe let's say we let u, an arbitrary function of x, equals to x minus 1 over 2. Therefore du will be 1 over 2 dx. Okay, and now we can substitute this into, or maybe I isolate the dx first. Dx will be 2 du. Okay, now we can substitute. So we have half of the integral from 1 to 2.5 of 1 over square root, and this this x minus 1 over 2, that is our u, right? So it's u squared plus 1, and this dx will substitute as 2 du. Okay, so there's no x anymore in this integral, so we can simplify some things a bit. This 2 and 2 cancels, so yeah, it just, everything is in terms of u now. So we have a du over u squared plus 1. Except this is still x, so we be mindful of this one. So this is still a x. The limits are still in x, right? So be mindful of that. So we just specify it as x. So when we integrate this, we can try and find from the formula sheet what form is this. This will be the integral of this a squared plus x squared. There will be the inverse hyperbolic sign. So inverse hyperbolic sign of u. U is, we have set it to be x minus 1. So I'm just going to rewrite as x minus 1 over 2. Right? This is our u value, and we have to substitute. Okay, so our boundaries or the limits are still in x, so I don't have to write x anymore. So just write like that, and therefore we will have substitute 5 over 2. We get the inverse hyperbolic of 3 over 4 minus inverse hyperbolic sine of 0. Okay, so if you can recall, if hyperbolic sine of 0 is 0, so this also goes to 0. But this inverse hyperbolic sine of 3 over 4, we want it in logarithmic form. So in case you forget how to derive the equation, it's fine, because it's given us in the formula sheet also that the relation of inverse hyperbolic sine is the natural log of x plus square root of x plus 1. Yeah, so we can just use this relation, and so we get the natural log of 3 over 4 plus 3 over 4 squared plus 1. So end up you should able to get the natural log of 2 as the final answer. Okay, so this is a slightly straightforward, a more straightforward integration question. And yeah, I hope you have tried and recall your integration techniques, your substitution or integration by parts. So in this case, we only use substitution, but it's a good practice anyway. So yeah, thank you for watching.